Ever wondered how battery or DC source can make something spin? We're breaking down how DC motors turn electricity into power you can see. Inside every DC motor, magnets and electrical currents push against each other, creating that rotation you see in everything from toys to cars. It's all about magnetic force. A magnet is an object that produces a magnetic force. And they have those two poles, north and south. Let's break down magnets and their interactions. Magnets have two poles, north and south. Think of them like opposite charges, where similar poles push each other away and opposite poles attract. If you had one magnet fixed by a bar, when you bring another magnet close with the north pole facing, they'll push apart. If you flip that second magnet around and approach with the south pole, they'll pull together instead. It's that constant pushing and pulling between poles that makes motors work. Think of a basic circuit like running water. The battery acts like a pump, pushing electricity through the wires. When the switch is on, it completes the path, letting the current flow freely to light the lamp. Turn it off, and you break the connection, stopping the flow instantly. Now, what happens if you flip the battery? Changing its polarity reverses the direction the current flows, though for most lamps, it still works and lights up. It replaces coil of winding instead of lamp. Imagine this circuit like a magnetic highway. The battery pushes electricity through the coil of wire, and when you flip the switch, it creates a magnetic field around it, turning it into a magnet. Now, if you flip the battery's polarity, that reverses the direction the current flows. This, in turn, flips the magnetic field around the coil, reversing its north and south poles. So these magnetic forces create a constant pushing and pulling. To keep the spin going, there's often a component in the motor that automatically flips the current at just the right time, reversing the magnet's poles. This means the push and pull never stop. They just keep changing directions to constantly push the motor around and around. Electricity flows out of the battery, goes through brushes that are holding tight against the commutator. Now, that commutator switches the direction of electricity as the rotor spins. Because the stator, or those permanent magnets, are always in one spot, the shifting magnetic forces on the rotor pull and push against them. That constant switching forces creates the continuous rotation you get as output. A DC motor transforms electrical energy from a battery into mechanical energy. Electricity flows out of the battery through the commutator, which flips its direction and into the rotor's coils, turning them into electromagnets. These electromagnets push against the stationary magnets outside, causing the motor to spin.